good night, Ram. Good to see you for a moment. It fits well that this presentation related to food systems resilience or lack thereof follows after the nature-based solutions to the construction sector, because these two sectors, construction and food, are the big issues for resilience and for mitigation in the climate context. It has been mentioned before that the construction sector may be accountable for up to 40% of greenhouse gas emissions, the food sector for up to 30%. Both matter in terms of energy use and for carbon, and both matter a lot for poor people, the living environment, and for the whole future of urbanization and resilience on both fronts. Our concept focuses on food system resilience as impacted and interacting with climate hazards, vulnerabilities, and exposure to food system risk. I underline that we need to distinguish between a risk, which are all potential outcomes and their likelihood of occurrences that are known, or at least where the probabilities of occurrences are known, and uncertainties where these are unknown. And science needs to work towards narrowing the uncertainties, but we will never find them completely understandable and predictable. So climate hazards are our big issue. The food system is under resilient stress, as shown in this graph. In the inner box, surrounded by the ecological or environmental context, you have four key building blocks who are interlinked: the nutrition and health, the agriculture and processing, the production sector, the market services, and the income and employment block. And this system is pounded by climate change, wars, macroeconomic and pandemic shocks, and other shocks. And these shocks are impacting on the interactions, on the linkages of these blocks. And that makes this system vulnerable at various entry points. Mind you, this is a simplified version of a food system. Food systems at global level, national and local level, have other complexities and other weight. The availability, safety, and diversity linkages and the efficiency linkages are critical in the inner part of the box. Non-resilient people in a non-resilient food system are stylized, are in this stylized presentation. You see, this is a time and well-being framework with a vulnerable path and a resilient path of people. And there is a poverty line drawn in this graph, the blue line, and a shock occurs and impacts on people, communities, or the whole economy in this system. The shock brings the non-resilient people who were slightly above the poverty line, below the line, and they don't bounce back in this graph. That's the reality of lots of poor people currently. The more resilient people also suffer from the shock, be it a drought or a fast onset disaster of a locust attack in East Africa, or be it an extreme short-term weather event. They bounce back. Now, there is only one shock shown here in this graph, which is, of course, a simplification. Bouncing back typically from extreme weather events such as storms, destroying infrastructure, livelihoods, etc., may take 5 to 10 years. So if we have sequences of shocks, the bouncing back of the non-resilient people is in jeopardy, and that draws attention to the tremendous equity effect in a non-resilient community situation. The food system is currently in deep trouble. This is drawn from the Food Security and Nutrition in the World report, which came out last week from FAO. World hunger rose further in 2021 following a sharp increase in the previous years already. Gains made until 5 years ago were lost in the last 5 years, and this year we'll see probably compared to 2020 about 150 million more people in undernourishment. Inequalities widened by the pandemic. Around 2.3 billion people in the world lack access to adequate food. So we are not talking about only the 800, only in quotation mark, 800 million people in undernourishment and hunger, but healthy diets are more and more becoming unaffordable for more than 2 billion people. In this situation, vulnerabilities are increasing, have been increasing. Small shocks have big impacts now. Smaller shocks have much bigger impact now than recently. However, past failures of food system resilience do linger on. What I've put in this graph is famines, so serious hunger crisis in the 20s and early 21st century. Now, the good news is in the middle column, the number of people killed by a famine has gone down in the last 3 decades. It used to be substantially higher. It related to war, but also to drought and lack of social systems of protection. But the prevalence of famines is still there, and we are now facing a situation that due to the complex crisis of the pandemic, which disrupted food value chains, the large expenditures which low and middle income countries had to make in order to protect people and with social protection measures have led to a serious debt crisis in many low and middle income countries. So the macroeconomic coping capacities are declined, and we have these high and volatile food prices due to shortages and due to the Russian-Ukraine war. On top of that, the lack of production responsiveness in the food system because of climate stress, especially droughts in large parts of the world. Not only in East Africa and parts of South Asia, but the heat stress in South Asia in particular, but also in parts of China and in Europe this year. So we look at a history of famines which is not over. And these are the predictions of the Food and Agriculture Organization. It shows you the uncertainty field in terms of increasing hunger in the coming in this and the next year. So it matters how we respond. It matters how investment is made. It matters how we engage to have markets working, and it matters how nature-based solutions enhancing resilience in smallholder communities is being applied and strengthened. I would now like to hand over to Alisher.
Thank you very much. And from the previous figure, we saw that now we are experiencing the rise in the number of people affected by food insecurity and hunger. And there are several reasons proposed to explain that. One of the important reasons is that climate change is already affecting food systems. Of course, COVID pandemic also had a huge impact on these numbers, increasing hunger, malnutrition, but also economic downturns. So these first three reasons were already known before the February this year. But then after the Russian invasion of Ukraine, these things got amplified tremendously, including in terms of sudden jumps in food prices, oil prices, fertilizer prices. Now what we are entering is a period of this volatility when food prices are skyrocketing in 1 month and then nosediving in another week because of fears of recession, but then again jumping again. So that's a very, volatility is becoming a new normal. Growing indebtedness among the countries already spent a lot of money to protect vulnerable during the COVID times. Now they don't have a lot of fiscal space left. They are highly indebted. Interest rates are rising. So this indebtedness problem is emerging and probably will be becoming a much bigger problem in the coming months and years. We mentioned about climate change. Now, if you look at this, these numbers, we can clearly see that over the last 60 years, the number of climatic disasters, recorded climatic disasters, is on the rise. And they involve droughts, floods, hurricanes, and so on. So there is clearly number of extreme weather events is increasing, and they will continue having more and more impact on our food insecurity and food systems. There are two scales when we are thinking about resilience. Resilience of people involving all these risks and uncertainties associated with that, shocks and resilience aspects, human capital, nutrition, but also resilience of systems, so larger scales, resilience of countries, regions, political systems. So often there is literature on both of these types of resilience, but they often do not overlap. They treat these things separately. So it is important that we embed measurement of resilience of people inside resilience of systems so that we can know the implications, cross-scale implications of breaks in resilience. This graph shows very interesting, very, very long-term trend in the literature in all the publications indexed by Google, starting from the 1800s, for some keywords. Words are very important. Words shape our worldview. Words shape our life, and the number of times we use them, that reflects what we are worried about, what we are concerned. So we can clearly see that over the last 2 centuries, the word famine was used less and less and less. But until sometime around 60s, around last mid-century, and then it somehow stabilized, but now it's on the rise again as part of the mentionings in the literature. So that reflects some concern among the people that famines are becoming a problem, perhaps increasingly so because of the impacts of climate change. And we can also see this concern about climate change resilience rising exponentially over the last 3 decades to 2 decades. And also we can see more attention being now emerging around food systems as well. here I will not talk about this, all the cause and effect relationship, how climate change affects food insecurity through diverse reasons, through productivity, through prices, through market services, and so on. But I also would like just to mention that besides climate change, there are a lot of other sources of risk to food system resilience, which also need to be taken into account together with climate change. But not all is gloom and doom. We have a lot of solutions, a lot of technological solutions, policy solutions, institutional solutions. And the best part about them, many of these solutions are known, tested in some perhaps specific areas. And then here we divided these solutions into these three categories following the conceptual framework presented earlier by Professor von Braun. So those which help to reduce hazards, those help to reduce vulnerabilities, and those which help to reduce exposure. Of course, there are some measures which overlap, which can be good for two or more of these aspects. So these measures also help not only with risk, so something that we know, we can calculate the probabilities of, but also with uncertainties. So some of these measures can include precautionary principles. This is of course, not a comprehensive list, but a list based mostly on those publications produced by UN Food System Summit, all these grassroots discussions, dialogues done by them, but also those publications produced at Center for Development Research, where we are from, at the University of Bonn. One of the key aspects which were mentioned in the UN Food System Summit is the importance of strong science agenda to make food systems resilient. And the key document of that scientific committee from that summit proposed 7 actions for promoting science agenda. First is improving policy and institutional innovations on healthy diets, but making sure that they are not standalone, but these are bundles of context-specific policies and institutional innovations. De-risking food systems and strengthening resilience, making food systems climate neutral, climate positive. And other aspects like land and credit, bioscience innovations, soils and land and water innovations, probably we'll talk a lot about these in the next presentations as well. Digital innovations, fisheries. So some of these measures are short-term, some of these are long-term. These are the 7 measures which are expected to help food systems more resilient through rigorous science and research. Okay, now let us come back to policy part. So that was what the science was saying. Now let us see how it is reflecting in the policy sphere. So this is a textual analysis of the COP26 Glasgow Climate Pact, so the final most important document of that COP, which contained more than 5,000 words. And it is difficult to believe, but water was not mentioned once. Food was not mentioned, not a single time. Land, 0 times. Agriculture, 0. Should we congratulate ourselves that nature was mentioned 2 times? Ecosystems, 3 times. So it's, I think, and most important mentioned words were agreement, parties, so more like this kind of procedure-based things. I actually, a couple of weeks ago, there was a big preparation conference for COP in Bonn, and I had the chance to be there and ask some of the country negotiators the question, why? Why is that? Why you are not mentioning food systems in that conference? And the answer was, we don't want to go sectoral. We want to stay broad. But I think that's not what IPCC is saying. IPCC is saying that every action needs to be sectoral, and without going sectoral, we cannot do big progress on addressing climate change. So I think that this is something that needs to change in COP27. So there is still some hope that it will, we will make more progress there. So in terms, and the last slide is about the specific action that perhaps are needed now to address our immediate food crisis. Some of these are short-term, like global cooperation to keep food and fertilizer markets open, no export bans. This is not working out very well now. Countries, after countries, are imposing new export bans, grain stock releases, controlling excessive speculation, which are making these food markets very volatile, reducing use of food crops for bioenergy, social protection, and also long-term investments on infrastructure, food systems infrastructure for resilience and research and development. Thank you very much.